So guys, here comes the toughest problem of this Neet Physics 2025, and I believe that giving this question to the Neet aspirants is a pure crime. And now let's solve this question. And I'm telling you early, this question is not for all, and this is quite a little advanced question. Let's first try to understand the question. There is a wall which is saying, and let's not consume more space because it requires a lot of space to solve this question. So there is a water, and there is a wall which is located at x is equals to L, and this is a water, and let's say this is angle theta naught, which is much less than 1. It's better to be remembered. This is theta naught, which is much less than 1. And now this water has raised, actually this is what we call it as meniscus, because it is formed some concave upward direction. So this is a meniscus, and if you look from other perspective, let's look it from other perspective. This is quite similar to this. Say this is our wall, and this is what happening here. This is a same angle theta. Now this y, this value from here to here, what we call it as y, and there are a few parameters given in our question, which is the density of the water, surface tension of the water, and this value y, and also acceleration due to gravity, and we need to correlate all of them. So which is not an easy task. By the way, before diving into this question, let's make sure that we know a few important things. First thing is that the pressure at this point is going to be P naught, and the pressure here also will be P naught. Now the pressure at this point is quite important. Let's call it as P here. So I can write P is equal to P naught plus, so P naught minus, as we are moving in upward direction. As we move deep down, the pressure increases, and if you are moving in upward direction, the pressure would decrease. So P is equals to P naught minus y rho g. This is your pressure at this point P. So pressure is this value. And the next most important thing is, whenever there is a concave side, let's say this is a water bubble, and if you are coming from atmosphere into the water bubble, then the pressure is going to be increased. So which we call it as excess pressure. So there will be some excess pressure, which we call it as 2T by R for drop and 4T by R by soap bubble. Now similarly here also there will be some excess pressure. So if this is P, now here the pressure would be P naught, but I can write P naught is equals to P plus P excess. So I can write again P is equals to P naught minus P excess. Now how do I find this value P excess? That is the most important part of this whole problem. To find the excess pressure, you need to use this Laplace equation. P excess delta P is given by surface tension upon the radius of curvature. Now the whole problem of this question is to find this radius of curvature. So before that, let's understand what is this radius of curvature. Let's say I have a graph. Let's say I have a graph y versus x, and I have got some function, normal function f of x. Now if you look at this point, if I want to find the radius of curvature, what is the radius of curvature? So if I draw a circle here which is just touching these adjacent points, so that the tangent to this circle is same as the tangent to this curve at this point. So this is what I am saying. So let's say this is angle theta. Now this radius of the circle, whose tangent and the tangent to the curve at this given point is same. So this radius of this circle is what we call it as radius of curvature, which is r here. So we need to find this r. Now if you look this small angle subtended, which we call it as theta itself, this is also theta, or again call it as d theta. Now this length, this small length, what we call it as, this we call it as ds, and I can write ds is equals to square root of dx square plus dy square. Small element along x direction plus y direction, because I can consider it as a right angle triangle. And now what I would get is dx is equals to dx into square root of 1 plus dy by dx whole square. This is what you would get from ds. And also, if you use some basic geometry, you can write ds is equals to r into d theta. Now let's find d theta. What is theta? Theta is nothing but the slope, so I can write tan theta is equals to dy by dx, which is our slope. Tan theta is equals to dy by dx. And since theta is very small, they have also given that sin theta can be considered approximately tan theta, which is approximately equal to theta. Now d theta, tan theta is equal to dy by dx. Now let's differentiate this term. Let's differentiate this term, which would give me d by dx of tan theta should be equal to d by dx of dy by dx. d by dx of tan theta is nothing but secant square theta. Secant square theta is nothing but 1 plus tan square theta. So 1 plus tan square theta. And again you need to do the chain rule, apply the chain rule. So it would be d theta by dx should be equal to d square y by dx square. So let's substitute d theta. I get d theta is equals to d square y by dx square into dx by 1 plus tan square theta. I can write it as 1 plus, what is tan theta? Tan theta is dy by dx. I can write it as 1 plus dy by dx whole square. Now let's substitute this equation here. By the way, we got ds. ds is equal to dx into square root of 1 plus dy by dx whole square. So which is also equal to r into theta, r into d theta. So let's substitute this. So I can write r into, what is d theta? D theta is d square y by dx square into dx by 1 plus dy by dx whole square is equals to dx into 1 plus dy by dx whole square whole power 1 by 2, because square root can be written as 1 by 2. Now let's bring this term there and dx gets cancelled luckily. So I get r into d square y by, there is x square, d square y by dx square is equals to 1 plus dy by dx whole square whole power 3 by 2, because there is 1 plus 1 by 2 is 3 by 2. Now I can write 1 by r. Can I write 1 by r, or are we doing anything else wrong? R into, instead of d theta we got this, perfect. So now we can write r is equals to 1 plus dy by dx whole square whole power 3 by 2 by d square y by dx square. Perfect. Now what would be 1 by r? 1 by r would be the inverse of this. Now let's use this equation. Delta p is equals to s by r. This is our equation. So I need 1 by r. So I will be getting from these two equations. I can write p naught minus y rho g is equals to p naught minus p xs, but p xs is s by r. This gets cancelled. So s by r is equals to y rho g. But s into, what is 1 by r? 1 by r is inverse of this, which is d square y by dx square into, I can write this whole term, into 1 plus dy by dx whole square whole power minus 3 by 2, because it has to be in numerator, which is equals to rho dg. Now I can take this term as 1 because look at this approximation, theta is much less than 1. So dy by dx would be tan theta, which would be much less than 1. So I can consider it as 0 approximately. So I can write d square y by dx square into s is equals to y rho g. So d square y by dx square is equals to rho g by s into y. This is how we solve this question. I know this is nowhere a NEET level question. This is completely straightforward from above JEE advanced level. I have learned this radius of curvature not even while my JEE prep. I learned it while I am doing my engineering. Now they are asking this whole part in NEET examination, which is quite and unjustified. I don't think this is justified, and I believe there should be some add mark to this question. Now let's move on to next question. Let's open this. Now this is done. Now let's move on to the next question. Question number 28. 28 is quite easy. 28 says that the pipe open at both ends has fundamental frequency F in A. So fundamental frequency of open pipe is given by F is equals to V by 2L. And what he is saying is that now the pipe is now dipped vertically in water column. Now this pipe is dipped vertically in water column, and let's say this length is L dash. Now the fundamental frequency of the air column is also same. Now the fundamental frequency, which is also same, let's say F, this is also F dash, which is V by 4L. Let's say this is L dash. Should be same as this fundamental frequency. So let's equate them, which is equal to V by 2L. So sorry, now question number 28. Here he says that there is open pipe which is both open at both ends, has fundamental frequency F in A. So we got open pipe both ends. Fundamental frequency F is given by V by 2L. Now this whole pipe is dipped in water. This whole pipe is dipped in water. This is whole pipe is dipped in water. And this length, new length, how much is this? Such that half of its length. So only half of the length is dipped, so remaining half will be L by 2. Remaining will be half, which is L by 2. Now this fundamental frequency of dash will be V by 4 into L dash, which is V by 4 into, what is L dash? L dash is L by 2 only. 2 ones, 2 twos, which is V by 2A. So I can see that clearly F and F dash are same. So F is equals to F dash. And question number 29 is theoretical question. See, the parallel plate capacitor made up of circular plates is being charged such that surface charge density on it. So whenever there is a parallel plate capacitor, now what happens is, so the charge keeps on increasing. Now due to increasing charge, there will be change in magnetic flux through this between this. There will be change in electric field between these two plates of the capacitor. If there is change in electric field, that would generate the magnetic field, right? So the magnetic field which arises due to this is going to be non-zero, because we got this Ampere circuital law, which is integral B bar dot ds bar, or B bar dot dl bar is equals to mu naught into I enclosed plus epsilon naught into d phi e by dt. This mu naught is constant. Now this is what we call it as Ampere's modified circuital law. So if you look carefully, now up until the field is changing, the magnetic flux will be non-zero, and it will be maximum among these imaginary lines which is connecting the peripheral of the cylinders or any shape. Now let's get back to question number 30. Now let's look into question number 30. So question number 30 is as follows. Now this is 2K, this is also 2K, and this is K. This temperature is given as T1, and this is T2, and they are saying this is maintained at temperature 3T, and this is at temperature T. Now we need to find the ratio of T1 upon T2. Now let's use the steady state condition. The amount of heat flowing through this conductor is equal to same as through this, and is same as through this too. So heat flowing through this is given by 2K into A. Delta T is 3T minus T1. By you will get L, but I am ignoring this for a while because all conductors are of identical. So I can also ignore the area if in case, to make this quite simpler. So 2K into 3T minus T1 should be equal to K into T1 minus T2, which should be equal to 2K into T2 minus T. Now let's take these two equations, then I will get 2K gets cancelled, and I will be getting 3T minus T1 is equals to T2 minus T. So let's bring here 4T is equals to 2T2 plus T1. Let's consider it as our equation 1. Now let's take these two equations. Now K gets cancelled. I will get T1 minus T2 is equals to 2T2 minus 2T. Now if I bring this guy here, then I would get 2T is equals to 2T2 plus T2 is 3T2 minus T1. Now this is our equation 2. Now what we do is equation 1 by equation 2, then I will get 4T by 2T is 2. 2 is equals to 2T2 plus T1 by 3T2 minus T1. Now let's cross multiply, which is 6T2 minus 2T1 should be equal to T2 plus T1. Now this goes here and this comes here. 5T2 is equals to 3T1. So T1 by T2 is 5 by 3. So this would be your answer. And then now we are heading towards question number 31. Another tough question as usual. You can solve this question in two ways. First, I will show you how to solve this using Kirchhoff's law, and then we will try to solve this using a normal method. So here is the circuit. You can try in many ways. You can also use Thevenin's theorem, which is not there for Neet syllabus, so let's not look into the Thevenin's theorem. This is 1 ohm, this is 3 ohm, this is 4 ohm, and this is 2 ohm. Now this is 50 volt. Now let's give some namings: A, B, they have already given the names, so let's not worry about it. A, B, C, D. We need to find current through CD. So first let's use some Kirchhoff laws and do this question. So let's say some total current I is going, and it has to divide here in two parts. Let's say this is I1, this is I2, and let's say here the current is I3, and the current here is going to be I1 minus I3, because total current is I1 and you are getting I3 here, I1 minus I3. Now what should be the current through this resistor? It should be I2 plus I1 minus I3. This is I2 plus I1 minus I3. Now the total outgoing current would be I1 plus I2, which is how much that is coming. I is dividing into I1 plus I2, and it is coming back as I1 plus I2, which is I2. Now fair enough. Now we have done the current distribution. Now let's apply Kirchhoff laws to this loop. Let's give some proper namings. A, C, D, A. Let's apply Kirchhoff law to A, C, D, A, which would give, we are going in the same direction, so this is I1, and we are coming in opposite direction, so this is minus I1 plus 3 into I2 is equals to 0. I can write I1 is equals to 3 I2. This is quite direct because they both are in parallel even. You can write that way also. And also you can write for this 2 into I3 is equal to 4 into I2 plus I1 minus I3. Now this is also correct. Is that correct? Now let's check once. This is 2 ones, 2 2's. So this is I3 is equals to 2 I2 plus 2 I1 minus 2 I3. But let's multiply by 2, then I'll get 2 I1 is equals to, let me turn off the alarm. Now if you look carefully, this is 2I1 is going to be 6I2, so 2I2 plus, instead of 2I1 I am going to put 6I2 minus 2I3. 2I3 goes there, then I get 3I3 is equals to 8I2. This is another relation that I got. 3I3 is equals to 8I2. This is what I am getting. Now let's apply Kirchhoff law to this big loop. Let's say A, B, C, D is done, E, F. Now let's apply Kirchhoff law to F, A, and let's go up. F, A, C, B, E, A. I'll write here. F, A, C, B, E, F. To this loop, we are going from here to here. Let's apply it this way, which is 50, and then you are going in the direction which is I1 into 1 is I1, and then minus 2 into I3 should be equal to 0. Fair enough. Now can we get anything? We got I1. Instead of I1 I can write it as I2. So I can write 50 minus, instead of I1 I can write it as 3I2 minus 3I2 minus 2 into, instead of I3 I can write it as 8 by 3I2. Instead of I3 I can write it as 8 by 3 I2 should be equal to 0. So 50 minus, if I take common I2, 3 2 is a 6, 3 is a 9, 9 plus 16 is 25, 25 by 3, this is 25 by 3 should be equal to 0. So I2 into 25 by 3 should be equal to 50, 25 ones, 25 2's. I2 I am getting it as 6 amperes. I got I2 as 6 amperes. So this is 6 amperes. Now once this is 6 amperes, this would be how much? 6 3s are 18, so this should be 18 amperes because they both are same. from this equation I1 is equals to 3 times I2. I2 I got it as 6 amperes. So I1 would be 3 into 6, which is 8 amperes, 18 amperes. And then next, what else we got is I3. You can also find I3. I3 is equals to 8 by 3 I2. Let's find out I3. What is I3? I3 is equals to 8 by 3 into what is I2? I2 is 6. 3 ones are 3 twos are, which is 8 twos are 16. 16 amperes. So this is 16 amperes. Now if you look carefully, total 18 amperes is coming and 16 amperes is going. The current through this CD would be I1 minus I3, which we figured it out. I1 is equals to 18. I1 is equals to 18 minus 16 is 2 amperes. So this is 18 minus 16, which is equals to 2 amperes, which is I1 minus I3. So this is how we solve this question. This is how we solve this question. Now we can also apply another way. We can also solve this question using another way without using this Kirchhoff's law. So you can use this 2 are in parallel, these 2 are in parallel. First we find the effective resistance, which turns out to be, let's do this way also. This is 1 ohm. This is 3 ohms. First you consider like this, they both are same. This is 2 ohms and this is 4 ohms. So 1 and 3 are in parallel, so 3 by 4. 4 and 2 are in parallel, 4 into 2, 8 by 4 plus 2, 6. 8 by 6 is 4 by 3. So this is 3 by 4. So I will be getting one 3 by 4 and another 4 by 3 are in parallel and connected to 50 volt battery. Now this would be 3 by 4 plus 4 by 3. How much is this? 3 by 4 plus 4 by 3 is going to be 4 3 is 12. 3 3 is 9 plus 6 25. 25 by 12. So the current I would get is V by R, which is 50 by 25 by 12. So 50, 25 was 25 was 24 amperes. See, this is what we are getting also. 18 plus 6 is 24 amperes. Total I am also getting it as 24 amperes. Now this 24 amperes has to be divided. Now it has to be divided such that let's say it is I1 and I2, such that I1 into 1 should be equal to 3 into I2, that is what we have written, and I1 plus I2 should be equal to 24. So from here you will be getting I1 is equals to 18, I2 is equals to 6. This value also same, you will getting I3 is equals to 16. Once you get I3 16, this as 18, then this would be 2 amperes. So this is how we solve this question. This is another tough question. You see NTA, how many tough questions you are given? Now let's do 32. 32 is already repeated question a lot of times from JEE mains. So I'll just give a quick explanation to this question. T is given by x square plus x. T is given by x square plus. Now if I differentiate this, then I'll get dt by dx, which is 2x plus 1. But dt by dx is nothing but 1 by d, because dx by dt is nothing but velocity. So dt by dx would be 1 by v. So 1 by v is equals to 2x plus 1. I need to find the acceleration. What is acceleration? Acceleration is v dv by dx. Acceleration can be written as velocity times dv by dx. So this should be, let's find dv by dx. We got v is equals to 1 by 2x plus 1, reciprocal from here. So dv by dx would be minus 1 by 2x plus 1 whole square into 2 chain rule. So which turns out to be minus 2 by 2x plus 1 whole square. And then if I look carefully, let's substitute this here. So acceleration is equals to v is nothing but v is 1 by 2x plus 1, 1 by 2x plus 1 into dv by dx. We are getting it as minus 2 by 2x plus 1 whole square. And how much is this? This is minus 2 by 2x plus 1 whole cube, which is option 1, I guess. This is option 1. Now this is also done. Now let's move on to question number 33.